welcome back to our Java series. Today we are discussing the third pillar of object oriented programming, abstraction. If encapsulation was about data security, abstraction is about managing complexity. It is the art of simplifying your software so that users can focus on what matters. By the end of this session, you will understand why the most powerful systems are often simplest to use. Let's get started. In simple terms, abstraction is the process of hiding internal messy details and showing only essential features. Think of it as focusing on what instead of how. When you use a microwave, you focus on what button to press to heat your food. You don't care about how the magnetron generates radio waves. In the programming, we want to provide a clean user interface for other developers, hiding all the complex implementation logic behind the scene. Look at this ATM machine on your screen. This is a perfect example for abstraction in the real world. When you want cash, you interact with the screen and the keypad. You enter the PIN and the amount, but you don't know how the ATM talks to the bank server. You don't know how the internal gears count the specific number of notes. All the implementation is hidden. You are provided with abstractive view of the bank's transaction system. You see the functionalities, but complexity is hidden. And that is what is called abstraction. In Java, we have two ways to achieve this concept. First, we have abstract classes. Think of this as partial blueprints. They provide anywhere from 0 to 100% abstraction because they can have a mix of concrete and abstract methods. Second, we have interface. These are the strict rules that provide 100% abstraction. Today, we are going to master the abstract classes in detail. So, how do we define an abstract class? We use the abstract keyword. Here are the most important rules. You cannot create an object of a abstract class. If you try to write new with the class name, then the Java compiler will stop. Why? Because the class is incomplete. It's an idea, not the reality yet. However, it can have constructors, static methods, and final methods which cannot be overridden. This is the common tricky question in the technical interview. Let's look at two types of methods you will find. An abstract method is a method that has no body, no curly braces. It's just a declaration that ends with a semicolon. It's a promise that says, I will do this, but I will decide how to do it later. A concrete method is a standard method. It has logic inside the curly braces. Abstract classes are unique because they allow you to do both in the same class. This is the favorite question. Why can't we create an object of abstract class? The answer is simple logic. An abstract class is incomplete. Imagine if Java let you create a shape object and then you called it the draw method. Since draw method has no body, the computer would have nothing to execute. It would crash or sit there confused. To prevent this, Java forbids the creation of objects for anything marked as abstract. Let's look at the code. We have an abstract class called shape. It has an abstract method called draw. Notice there is no body. The circle class comes in and says, I am a shape using the extends keyword. Because circle is concrete, it must provide the body for draw. It fulfills the promise made by the parent. This ensures that every specific shape in your program knows how to draw itself. Why do we do abstraction? Security comes first. You hide the implementation so others cannot accidentally break your logic. Loose coupling. You can change how circles draw itself without ever touching the shape class. Next comes reusability. You can write a single piece of code that handles any shape, whether it's a circle, triangle, or square. Here is your cheat sheet. A regular class can create objects and has only concrete methods. An abstract class cannot create objects and can have both the methods, that is abstract and concrete. Remember to use the abstract keyword for the classes and methods that have no body. Here are the golden rules for you to remember. Rule number 1. If even one method is abstract, the whole class must be declared as abstract. Rule 2. If you inherit from the abstract class, you must either override all its methods or you must also be declared the class as abstract. And yes, abstract class have constructor. They are used to initialize fields when the child object is born. That wraps up our lesson on abstraction. If you have any question, put it down in the comment section. If not, join me in the next module where we explore interfaces, the way to achieve 100% abstraction in Java. Thank you for your time and happy coding.